Chapter 4, Section 6 is called Integration by Parts, which is this formula, but integration by parts is really more of a strategy. On page 452, exercise 2, the integral of 3x e to the 3x dx. We take this 3 that's multiplied and move it to the left of the integral sign. Integration by parts works like this. We let u equal one part of this and dv equal the rest. And we'll discuss in class how to decide which part to let u equal and which part to let dv equal. So integration by parts, one of the parts that's here will be called u, and the rest of it, the rest of what's here will be called dv. From u we get du. If u equals x, then the derivative is 1. So du, the derivative of 1x is 1. So du equals 1 dx. And over here where we have dv equals e to the 3x dx, we do this with both sides. Look at the purple. The integral of dv is v. And on the other side here where it says the integral of e to the 3x dx, we have to do this. We have to let w equal the exponent, 3x. dw, the derivative of 3x is 3, so dw equals 3 dx. This is where I say, I wish this said 3 dx. It says 3 dx, but I wish it said 3 dx. So abracadabra. I'm allowed to write that 3 that just appeared there as long as I also write the 1/3. We have 1/3 the integral of e to the w, 3x equals w, dw, 3 dx equals dw. I use w just because u is already used over here. V equals 1/3. The integral of e to the w dw is e to the w. There should be a plus c here, but it's best to not write it. Don't write the plus c until we're back here at the original problem. V equals 1/3 e to the w, but w is equal to 3x. So back to the original. Bring down the 3, bring down the integral symbol. This x we're calling u for a while. The rest of this is what we're calling dv. So I said the x we're calling xu. All the rest of this we're calling dv. Just read what's written over here. The integral of u dv is always equal to uv minus the integral of v du. And this 3 here means 3 times all of this. So every time we write the integral of u dv, anytime we write this, the next thing we write should be this. Now in the next step, we're going to distribute this 3 and also turn all these things back into what they equal. 3 u, look around for what u equals up there. V, look for v, it's over here. 1/3 e to the 3x. Copy the minus. Here's another 3 because distributing this 3. Then this integral symbol, followed by v again. That's 1/3 e to the 3x. And then du is up here. It's dx. So all of this right here is x e to the 3x, because 3 times 1/3 is 1. Minus, here's another 3 times 1/3, so I'm going to just write 1 integral e to the 3x dx. And we just did this, but I'm going to do it again for review. If I let w equal this exponent, then the derivative of w is 3. The derivative of 3x is 3, so dw is 3 dx. So I look over here and say, I wish this said 3 dx. Okay, it does. So I need a 1/3. If I put in a 3, I got to put in a 1/3. Copying. So that was a 1, but now it's a 1/3. Integral e to the w dw. And the integral of e to the w dw is e to the w plus c. So can't leave the final answer with this w. So the final answer is copying all of this, x e to the 3x minus 1/3 e to the 3x plus c. And I would recommend you check this answer. So take the time to find the derivative of this answer and make sure, if that's the right answer, the derivative of that answer will be this inside the green. So you should check that out, make sure it's right. I'll do one more example of integration by parts. This one is number 10 on page 452. It's the integral of x to the 3rd times the natural log of x dx. Here's how integration by parts works. We let u equal a part of this. And then dv has to equal everything else. We'll discuss in class how to decide which part to let u equal. Whatever u equals dv is everything else. From u we get du. The derivative of the natural log of x is 1 over x. So du equals 1 over x dx. When we have dv equals something, we take this purple pen and show you we do this to both sides of that, because the integral of dv is just v. The integral of x to the 3rd dx is x to the 4th over 4 plus c. Do not write the plus c. So here's the original. This right here that I'm circling is equal to u. It says that right there. The rest of this, x cubed dx, all of that is equal to dv. X cubed dx equals dv. The integral of u dv is always uv minus the integral of v du. Always. The integral of u dv is always uv minus integral v du. In this exercise, u is up here, the natural log of x. V is down there, x to the 4th over 4. Copy the minus, copy this integral sign. V is over here, x to the 4th over 4. And du is that, 1 over x dx. So we replace u with what it equals, right there. We replace v with what v equals, right there. We replace this v with what v equals. And we replace du with what du equals. This multiplication can be left like that, or it would look better if we wrote x to the 4th over 4 times the natural log of x. After this minus, we can rewrite this as 1/4 the integral of x to the 3rd dx. because there's a 1 and there's a 4 down there. So we take the 1/4 to the left of the integral symbol, and we have x to the 4th up here and x down here. X to the 4th over x is x to the 3rd. So copying some more, x to the 4th over 4, natural log of x, minus 1/4. And here we have an easy integral. The integral of x to the 3rd dx is x to the 4th over 4. The final answer to exercise 10 is x to the 4th over 4 times the natural log of x minus x to the 4th over 16. That's what this times this equals, plus c. You should check this answer, make sure the derivative of this answer, it would be good practice to find the derivative of this answer. And if that's the right answer, the derivative of that answer will be what I'm putting this green around. It's really important to know how to check. The next section is Chapter 5, Section 1. So Chapter 5, Section 1. Please carefully read the pages in the textbook that explain what equilibrium point, consumer surplus, and producer surplus are. Read those pages in the textbook to see what these things mean. In this video, we will do an example to show how to find these things. Equilibrium point, consumer surplus, and producer surplus. We're going to do page 479, exercise 6. It says d of x equals x minus 8 squared. And it doesn't say this, but that's the same. X minus 8 squared is the same as x squared minus 16x plus 64. It also says s of x equals x squared. And in the directions, it says d of x is the price in dollars per unit that consumers are willing to pay for x units of an item. In other words, d of x is the demand function. S of x is the price in dollars per units that producers are willing to accept for x units. We call that the supply function. Part A says find the equilibrium point. Equilibrium point are where d of x is equal to s of x. So we set these equal to find the equilibrium point. We set the demand, x squared minus 16x plus 64, equal to the supply. Subtract x squared from both sides. Subtract 64 from both sides. And divide both sides by 16. X is the number of units that are produced or sold. Plug 4 into either one of these, and we'll get what I'm going to call y. Plug 4 in here, we get 16. If you plug 4 in here, you'll get the same thing. So you use either one or both as a check. So this point, a point has an x coordinate and a y coordinate. The x coordinate is 4, and the y coordinate is 16. But this when we plug a number in these, we're getting a price. So we'll attach a dollar sign to that. 4 units at $16 per unit is the equilibrium point. That's the answer to part A. Part B is asking for the consumer surplus at the equilibrium point. So part B, asking for the consumer surplus at the equilibrium point. That means at the point 416. So here's the formula for that. The consumer surplus at a given point is the integral. It says from 0 to q. By q, it means the first coordinate here of the d of x function. That's this function, x squared minus 16x plus 64 dx minus, see here, minus q times p. That means minus 4 times 16. These numbers are referred to as q and p in the formulas up here. Q is like a quantity of things. P is a price. So here's the integral. It's the integral from 0 to q. That means in this example from 0 to 4 of the demand function dx minus q times p. In this case, q and p are 4 and 16. So if we do this integration, the integral of x squared dx is x to the third over 3. Copy the minus, copy the 16. The integral of x dx is x squared over 2. Copy the plus, copy the 64. And the integral of dx is just x. Instead of writing plus c for this integral, we put a bracket with 4 and 0 attached. And then bring down this minus 64 because that's what 4 times 16 is. 16 over 2 is 8. So we have x cubed over 3 minus 8x squared plus 64x bracket 4, 0. Bring down that minus 64. The bracket means everywhere there's x, we're going to put 4. 4 to the third over 3 minus 8 times 4 squared plus 64 times 4. And then it's minus, every x gets replaced with the number down here, but this number is a 0, and when x is 0, this will be 0 minus 0 plus 0. Don't forget to bring that down. So put all of this in your calculator carefully, and it rounds to $85.33. That amount, $85.33, is called the consumer surplus at the equilibrium point. And the last part of this question, part C, is to find the producer surplus at the equilibrium point. Part C, the producer surplus. So that's this formula right here. This formula starts out with q times p. So it's, in this example, it started out with 4 times 16, q times p, minus the integral from 0 to q. That means from 0 to 4 of the S of the supply, S of x. That's right there. dx. 4 times 16 is 64, minus the integral of x squared dx is x to the third over 3. Instead of writing plus c, put a bracket with 4 and 0 attached. The part with the bracket means, I'm going to ignore the 64 and the minus for a minute. The bracket means, right, 4 to the third over 3 minus 0 to the third over 3. And that 64 minus means 64 minus whatever we get here. So we can get this answer and then 64 minus it. So do all this calculation in your calculator, and it comes out to be $42.67. That number, that amount is called the producer surplus.